Isoelectronic series. All right, I just want to talk about that again. What does the prefix iso mean? Same. Iso means same. Okay. Electronic means electrons. Okay. Same electrons. Same electrons. Okay. Isoelectronic means we're talking about atoms or ions that have the same number of electrons. Okay? Which means the only thing that's different about them is going to be their number of protons. That's an isoelectronic series. Okay? So if their protons are the same, then that means, or if their protons are different, then they have different nuclear charges. So do me a favor, take a second and look at this. You have the oxide ion. You have the fluoride ion. You have the sodium ion, the magnesium ion, and the aluminum ion. They're giving you proton information, electron information, and size information. Take a minute and look at that. Look at how much smaller aluminum is than oxygen. To some degree, that probably surprises you. Because if you just look at the periodic table, where's aluminum? In the third energy level, 3p. But we're not talking about aluminum the atom. We're talking about aluminum the ion. So what did aluminum do? It lost 3, which means how many does it have now? 10, which puts it where?
Neon.
Where neon is, right? If aluminum gives away 3 electrons, keep in mind the whole reason they're gaining or losing is to have a complete outer shell. The question is, are they adding to fill up the outer shell they already have? Or are they losing so that they have a complete outer shell that they already have on the inside? And that's like a statistical game, like which way's easier, okay? So if aluminum gives up 3 electrons to be like neon, it doesn't end in 3p anymore. Where does it end? 2p, okay? So it's pretty small. They all end at 2p, because look at them. They all end at 2p. So the main difference between them is how many protons they have. And what is aluminum's nucleus going to be able to do? Way better than oxide's nucleus. It's going to be able to pull those 2p electrons in because it has almost twice as many protons. Correct? So that's why it's significantly smaller than the oxide ion. All right? Now, again, you're going to do a sample problem. Go to 267. Go to 267. And we'll look at the sample problem on that page. And then you'll do the practice exercise. But let's do sample problem first. Okay? So you have K plus, Cl minus, Cl minus, what does it say? Ca2 plus and S2 minus. Okay. So take these and put them in order of decreasing size. Decreasing size. Okay. Okay, so what do we get here? Decreasing size. So who's the biggest? S2 minus. Why? Hold on a second. How many electrons do all of these have?
18.
They all have 18.
Well, from ground state.
Well, hold on. They all have 18, which means they all have the same amount of protons, okay, or electrons. They all have the same amount of electrons, okay, which is 18. What's different about them? The protons, okay? How many does S2 minus have? 16. How many does chloride ion have? 17. How many does potassium have? 19. How many does calcium have? 20. Why is sulfide the smallest, or the biggest?
It has the least amount of attraction.
It has the least protons. Like it has 16 protons trying to attract the same 18 electrons. Okay? So you just put these in order of protons, and you have your order of size, right? Because they all have 18 electrons. Okay? So this is going to be the biggest. Then chloride. Then potassium. And then calcium. Does that make sense? Okay. All right. So that's what you're looking at. Okay. So the calcium ion is the smallest because it has more protons that are able to pull in those electrons. Okay. Now do the practice exercise that's there too. Okay. In the isoelectronic series, calcium or Ca2 plus, Cs plus, and Y3 minus, which ion is the largest? Okay. I'm erasing. So what is it? Ca2 plus, Cs minus, or plus, and Y3 plus. Is that right? Yeah. Okay. And it says which one's the largest. Okay. So are these isoelectronic, by the way? No, they're not. Okay, calcium has 20 protons and 18 electrons, right? Cesium has 55 protons and 54 electrons. And yttrium has 39 protons and 36 electrons, right? So who would be the biggest? Cesium. Right, it has extra energy levels compared to these other ones, doesn't it? Okay, so this is the biggest. Okay, you guys, these types of questions where they're having you compare atoms and ions, okay, those are the types of questions you're likely to encounter in a multiple choice section, where they're not telling you what to think about. Like, you have to think. So it's not like, which way is the trend? And they're all in the same row or column. You know, like, they're mixing it up with columns, rows, all sorts of things. Atoms, ions. And you've got to have such a good understanding of this that you can handle it no matter what they throw at you. Okay? So practice the reasoning, because that's really what makes it more understandable. Yeah?
So will they not give us columns like N